The laws of physics tell us about all possible phenomena and entities that could, in principle, arise in our universe. However, only by observing, measuring, and experimenting with the real universe can we determine what can actually occur. One of the very first consequences of Einstein's general theory of relativity was the black hole, a region of space with such a concentration of matter and energy gathered in one place that nothing, not even light, can ever escape from this volume. But mathematically, this phenomenon has an opposite side, the counterpart to a black hole, a white hole from which matter and energy would spontaneously emerge. Hello, dear friends. In today's video, we would like to tell you about one of the most intriguing mysteries of the cosmos, white holes. In this video, you will learn what they are, how we discovered them, and whether they are real. Before we begin, we would like to ask you to subscribe to our channel and click the bell icon to be the first to see our new exciting videos about the mysteries of the universe. Black holes, as numerous observations have shown, are not only physically real but also quite abundant in the universe. But what about white holes? What are they, and do they exist physically? After all, this is one of the most captivating and unusual phenomena allowed by physics. Let's take a look at what we know about this. The idea of white holes makes much more sense if we start with its more familiar counterpart, the black hole. This idea was first proposed in the 18th century by John Michell, a priest from the village of Thornhill, a prominent English natural philosopher and geologist. He called these objects dark stars and understood that, like all other masses in the universe, they have their escape velocity from the surface. That is, the speed needed to completely overcome the gravitational attraction of the body. And if you gather enough mass in a small enough volume, this escape velocity will reach or exceed the speed of light. Since nothing can move faster than this speed, such objects will only absorb light and matter but will never emit them within a certain region in space, now called the event horizon. In 1915, Einstein's general theory of relativity was published, displacing Newtonian theory and replacing it with a more general law of gravity. However, black holes did not disappear. In 1916, it was shown that they arise when solving equations within Einstein's theory. Versions of black holes with electric charges and angular momentum were also discovered. Again, with a sufficient amount of mass in a certain region of space, the appearance of a black hole became almost inevitable. One interesting thing that should happen within the event horizon of a black hole, according to the laws of relativity, is the formation of a singularity. The singularity, sometimes jokingly referred to as the place where God divides by zero, is where the laws of physics break down. In the case of a black hole, it is the place where the rules describing space and time are no longer applicable. It's as if, in this place, you only get nonsense as an answer to any physical question you may ask the system. We discussed black holes in more detail in the video, which you can watch by following the link in the top right corner. So, if much is understood about black holes, what about white holes? There are two ways to think about this. One can simply acknowledge that the predictions of the general theory of relativity are time-symmetric, meaning that objects move, accelerate, and interact by the same laws in opposite scenarios. That is, matter that collapses, forming an event horizon and then a singularity or a black hole, follows exactly the same rules as the singularity from which matter and energy, as well as space and time, emerge. Considering the case of a time-reversed black hole is one way to envision a white hole. Another way to describe a white hole, instead of reversing the arrow of time, is to think about what would happen if we reversed space instead. The space inside and outside the event horizons of a black hole behaves in very similar ways. This means that if we imagine the black hole turned inside out so that each point inside the event horizon now corresponds to a point outside the event horizon and vice versa, we get an inside-out black hole, which can now be designated as a white hole. One question that often interests physicists is, when something crosses to the other side of a black hole's event horizon, where does it go? Of course, one could simply state it goes into the singularity of the black hole, but this answer tells us nothing, especially since we know that at this point the laws of physics break down. One possibility often considered is that the singularity might not only be a point where everything simply falls into after entering the event horizon, but also a point from where everything comes out. Instead of being just the end of the story for matter, it could be the beginning of a new, different story. In other words, it is quite plausible that events corresponding to the emergence of a large amount of matter and energy at a specific place and time could occur. In our universe, not only black holes, but also white holes may exist, places where everything starts from an initial singularity. Physicists believe that, in many ways, this is reminiscent of the remarkable event that happened 13.8 billion years ago, the hot Big Bang. This suggests that there may be a connection between black holes and the birth of a new universe. Every time a new black hole forms in our universe, isn't there a newly born universe somewhere on the other side of the singularity analogous to a white hole? Does this mean that our universe and our own hot Big Bang originated from a state not much different from the state of a white hole, and perhaps all of this happened due to the existence of a previous universe that formed a black hole, leading to our appearance? Even if we don't observe any evidence of the existence of white holes in our universe, the fact that we had the Big Bang and the fact that our universe has black holes are consistent with the idea that at the other end of every black hole that has ever been created, there might be a white hole. In fact, if you look really deep and ask what happens when you fall beyond the event horizon of a rotating black hole, it turns out that what you experience is very similar to what, in our opinion, our universe experienced just before the onset of the hot Big Bang, a period of exponential expansion. Today, we call this phenomenon cosmic inflation. But do white holes really exist? In reality, we have never seen such holes, and we don't expect to ever find them in our universe. Event horizons unfortunately very effectively hide everything that happens on the other side of them. Perhaps there is something very interesting at the central points inside each black hole in our universe, but we probably will never be able to gain access to them. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to not miss new exciting videos about space and the universe. Write in the comments what you would like to learn in the next video. Thank you, and see you next time.